rectangle, square, right? There's a lot of four-sided figures. But the generic name for a four-sided figure is what we call the quadrilateral. Okay. Quad means four. So quadrilateral is a four-sided figure. Okay. 5 is a pentagon. There's actually a building in Washington, D.C. called the Pentagon, and that's where like the CIA and some of the government. It did get hit by a plane in 9/11. Yep.
Wait, where were you in 9/11?
I was actually in my classroom in my first year of teaching when 9/11 happened. Kind of a crazy experience for your first year of teaching. What do? Do you keep teaching? Do you? Yeah. We eventually stopped and kind of
So was why you were
pressed.
teaching?
My mom said that in her classes they watch the news and all the other teacher just kept teaching. It's like there's not anything about it.
There's nothing you could do about it. And so, but yeah, it was, we ended up not practicing football that day too. Yeah, I mean, like it was just, yeah, kind of crazy. One of those things that makes you reflect, but you also know where you're at that first day, that day.
He was a chaplain.
Oh, really?
Yeah.
Wow. Like right after it happened? Yeah.
He's a pastor. Well, not kind of.
He is.
Pastor for like
Yeah.
30 something.
Yeah.
That was so much worse than mine.
Okay, 6-sided is a hexagon. 7-sided is a heptagon. Okay, all of these just have different prefixes. Gon is just sides. So 5 sides, 6 sides, 7 sides, so on. 8, octagon. Like an octopus has 8 tentacles, and octagon has 8 sides. 9 is a nonagon.
Which side figure are you? Like and like none, like and
No.
Oh,
Sorry, N-O-N. Yep. 10 is a decagon. A decade is 10 years, so the prefix dec means 10. What'd you say? Decagon is 10. Okay. 12 is a dodecagon. Okay.
Why would you skip 11?
Good question. Mainly because 11 is not a figure that we're going to see very often. I mean, we don't see 12-sided figure very often, but every once in a while we might. 11-sided is not one that we're going to see. So don't really have a name for it. And really anything after 12, then we just call it, like if I have a 13-sided figure, we just call it a 13gon. Okay, we don't have any special names for it because, so that's what we would do for 11 too. We would just call it an 11gon. 42 sides would be called 42gon. Tomorrow, show me what a 42gon would look like. Show me tomorrow, draw a picture tonight of a 42gon, and let me see what it looks like. Okay. Oh, I don't doubt that you will. Okay. Convex, concave. So this goes for all polygons. Okay. All polygons can either be identified as either convex or concave, one or the other. It can't be both. Okay. So a convex polygon basically means all sides are pointing out. If I connect the vertices of these, all the vertices are connected on the inside of the figure because all of the segments are pointing outwards. Okay? I kind of think of it as like it's flexing. It's flexing out or it's vexing out. Okay? Concave then has just the opposite look to it. And it doesn't have to be all sides, but this piece right here, these two sides cave in, right? So when we think concave, two of the sides are going to cave in towards the middle. If I were to connect these together, it's on the outside of the figure because the sides cave in. Okay, when I connect these together, they're all on the inside. Okay, so on convex, all of the segments in the inside are connected inside the figure. Here, I could connect some of these, like this one and this one together and be inside, but if any of them are connected to the outside, then it would be a concave polygon. All right, on part A and B here, we're going to identify it by its number of sides, and then finally, whether it's convex or concave. So first up, we're going to name it by its number of sides. We got 1, 2, 3, 4 sides. Okay, so 4 sides is called a quadrilateral. Hey, and what do you think? Convex, concave? Concave. And one way you could do it is when I connect those two together, they're connected on the outside of the figure, not the inside of the figure. Okay, when you got more sides, one thing I always kind of like to do as you're counting it, just so you remember where you start, because some of these might have a lot of sides to them. So I'm going to start at the top and go 1, 2, 3, 4, 5, 6. Just count as you go, just so we remember where we start at. So we have a hexagon. Okay, and this one is convex. If I connect all of these vertices together, all of them are going to be connected on the inside. There's no vertices that I can connect that would be outside of the figure. They would all be on the inside. So all of the segments are flexing out. Okay, here we got a lot of formulas today. Okay, we got 4 different figures here that we're looking at finding the area and perimeter of. Okay, when we talk about perimeter, we are talking about the distance around the figure. When we talk about area, we're talking about like the space inside of that figure. and so when we think of area, like we might use area when we talk about, like, if I have carpet in my living room and I want to put some new carpet in, how many square feet of carpet would I need to replace it, right? If I have a yard, my backyard, and I want to put some grass seed down, then you would want to know how many square feet is my backyard, or fertilizer, or something like that. Then when you look at the package, it'll tell you how much seed or how much fertilizer you would need for that space in your backyard. So that's where we would use area. Perimeter, circumference on a circle, but perimeter, if it's a polygon, perimeter is the distance around. Where you might hear the word perimeter, if you ever watch like a prison movie, and sometimes maybe the inmates maybe escape, and they'll say secure the perimeter. That means make sure, let's lock down the outside, make sure they don't get any further away. So it's the distance around the outside. It'd be like the fence around the outside of a yard would go around the perimeter of the yard. Okay, so here, perimeter of the triangle, we add up the 3 sides on the outside, A plus B plus C. For the formula for area of a triangle, 1/2 base times height, or sometimes people like to do this, base times height divided by 2. You're going to multiply the base and the height. The height has to be perpendicular to the base. So we have to use the piece that's perpendicular. Notice that in this case, the height is not a side of the triangle, okay? It could be if I had a right triangle like this could be my base and this could be my height. So the height could be a side, but it doesn't have to be a side. But it does have to be perpendicular. It has to make a right angle. Okay, a square, we have 4 congruent sides, 4-sided figure. What's something special that we know about a square? All sides are the same. So I could say 1, 2, 3, 4 and add up all 4 sides, but because all 4 sides are the same, I simply could just take 4 times whatever the side length is. If the side length was 7, I would take 4 times 7. Okay, to find the area, we're going to just do 7 times 7. Length times width, base times height, however you want to think of it.
Instead of like all different letters, why wouldn't they just put X for each?
Well, they could, right? Here, the reason why we're using these letters is because, like here, the little b stands for like the base or the bottom of the triangle. H would be the height. A and C don't really have any meaning, okay? So you could use some different letters there, for sure. S here would be like the side, the length of a side of the square. So that's, over here, we're using L for length and W for width of a rectangle. So we're trying to just use variables that maybe kind of identify.
You could just use X for like.
You could, yeah, you could, for sure. Okay, rectangle, we have 2 lengths and we have 2 widths, so it's just 2L plus 2W. Opposite sides are congruent, so these are the same and these are the same. Over here, the only thing that we would really do for a parallelogram, because perimeter would just be distance surrounded again, okay? But base times height. And once again, the height may not be, probably won't be the length of a side, okay? It'll be on the inside of the parallelogram, has to be perpendicular to the base. So those are a bunch of formulas that we're going to see based on the type of figure that we have. All right, perimeter and area of each shape. So the first thing we need to determine is what kind of shape do we have on the one on the left? Rectangle, okay? How do we know that this guy is a rectangle? Okay, we got 4 sides, we got 4 right angles, okay? And the reason why it's not a square is because the length and width are not the same lengths, right? 2 different lengths, so the length and width would be different. Still 4 congruent angles though. Let's start with the perimeter. Perimeter is 2 times the length plus 2 times the width. Okay, and some people ask, can I just do 86 plus 51 plus 86 plus 51? There's nothing wrong with that, okay? This is maybe just a little bit shorter way of writing it out. But yeah, you could just add up all 4 sides and it would be fine. Okay, if we add up all of that or put that into our calculator, what do we get for our perimeter? Let's try putting that in. 274. Okay. And our label here is inches. It's inches because inches is on the original picture. Okay, our area is length times width or base times height, whatever you want to call it. So it would just be 86 times 51. So we get, okay. Now the label here, labels are going to be something we're going to have to pay attention to. Because we're talking about area here, it's always square units. So any type of area is always square units. We're talking about how many square units are on the inside of this rectangle, that gray area on the inside. If you go to like buy carpet or buy something to cover something, then you would need to know how many square feet or inches you need to cover, okay? And so when you go look at the price of it, it's going to be priced at per square feet or whatever unit you're using. Okay, picture on the right here, we have a triangle. So we're going to use the formula for a triangle. Start with the perimeter here first. 13 plus 13 plus 10. Add up all three sides. 36. Okay. So as long as I know the sides, finding the perimeter is pretty easy. Okay, area here, and this is what we talked about. Notice the 90-degree angle here. This would be my height. This would be my base. So I'm going to label this as H. I'm going to label this as B. And so we're going to go 10 times 12 divided by 2. Okay, I probably prefer writing it out like that rather than 1/2 times base times height. That way you don't have to worry about the fraction. Multiply the base times height and divide it by 2. 60. And then this would be square centimeters. All right, so here's where this kind of ties into what we did earlier in the chapter. Earlier in the chapter, we talked about finding the distance and the midpoint of certain things. And we won't necessarily use the midpoint here, but we are going to use distance in certain scenarios. So as we look at this one here, first thing we're going to do is we're going to plot the 3 points that we have. So we're going to go over 1, up 3, which should be D. Over 4, down 3 would be E. And then left 4, down 3. We're going to connect our 3 points together. And that would be our triangle. Okay, we want to find perimeter and we want to find the area. Okay, I'm going to start with the area in this case because I think the area is a little bit easier to find on this one. It really doesn't matter which one you start with because we got to find both. Hey, the reason I'm going to start with the area is we're going to take base times height and divide it by 2. The base is my bottom side, is what we typically think of our bottom side. It doesn't have to be the bottom side, but the reason I'm going to use FE here is because it's horizontal, okay? And because it's horizontal, all I have to do is count how many units from F to E. Don't start here, okay? We're going to start, we've moved 1, 2, 3, 4, 5, 6, 7, 8. So we're going to move 8 units to get from F to E. That would be my base. Okay, then we're going to look for the perpendicular height. Okay, you can draw that in lots of different places, but usually we're going to go from the top of the triangle down to the base, and it's going to be perpendicular at that point. Okay, it's got to be straight up and down. So if I'm going to count vertically here, from the base to this point, I go 1, 2, 3, 4, 5, 6. So my height would be 6. So we're going to go 8 times 6 divided by 2. Okay, this problem is not labeled with centimeters or inches or anything like that. So our generic label that we're going to use here is units, 24 units squared. Okay, and one of the things that you might notice or that you could do here is you could count all the units inside of this, and it would be kind of difficult because some of them are like partials, but like if I looked at how many full square units would be in here, this would be 1, 2, 3, 4, 5. I could count up those square units. That's how many units would be inside of that triangle, okay? And we really can't do that. We can't count it because some of them are partial and it'd be kind of like putting a puzzle together to kind of piece it all together. So we wouldn't do it that way, but that's how many square units would be inside of that. Okay, perimeter, we have 3 sides, right? We know one of the 3 sides is 8, okay? That's the easy one. The other 2 are going to be a little bit more difficult here, mainly because when I go from D to E or D to F, it's not vertical or horizontal, So I can't just count. I can't go from D to F and say 1, 2, 3, 4, 5, right? Anytime it has a slope or it's slanted like that, I can't just count like that. So I have to have another way of finding the length of that side. Well, what have we done so far this year that I can use to find DE? What have we done when we've had something like that? So I'm looking for what we call the length of that side, but what's another word for length?
Distance.
Distance. We have formula for distance, right? So we get to use the distance formula again, okay? Just when you thought you were done with it, here it comes again. Okay, and I'm going to do DE first. Remember when I write DE, DE means I'm finding the distance between D and E, right? So, these are the 2 points that I'm going to use. So we're going to go 4 minus 1 squared plus negative 3 minus 3 squared. Okay, and we're just going to kind of go through step by step here. 4 minus 1 is 3. 3 squared is 9. Okay, so this would become 9. Negative 3 minus 3 would be negative 6. When I square negative 6, it makes 36. Should be a positive. And 9 plus 36 would be radical 45. Okay. For right now, I'm just going to leave it as radical 45. So we're going to say 8 plus radical 45 plus, and then I got one more piece I got to find. Okay. I still have to find DF. So if I find DF, we're going to use D and F. We're not going to use E, right? We're going to use these 2 points because we're trying to find the length between those two. So we're going to go negative 4 minus 1. And then we're going to go negative 3 minus 3. Negative 4 minus 1 would be negative 5. Negative 5 squared would be 25. Negative 3 minus 3 would be negative 6. Negative 6 squared, 36. 25 plus 36 would be 61. Okay, this one we didn't have to round because it was a nice whole number, right? This one we're going to have to round. But the reason I'm leaving it like that is because I don't want to round until the very end. I don't want to round this answer, and then round this answer, and then round again at the very end. I want to wait and round one time at the very end of the problem. So I'm going to put this whole thing into my calculator. Depending on what kind of calculator you have, you just got to be a little bit careful, okay? So we're going to go, if you have your calculator, let's try putting this in, just so you know how to put this in. Really doesn't matter what we start with, but let's go 8 plus square root of 45 plus the square root of 61. And hit equals. Okay, and it should be a decimal. Okay, anybody need help? Calculator? Everybody's okay with typing that in?
Do you have a calculator charger? I see that there, but I forgot to
Charger?
Yeah. For a calculator?
How much do you count off if it says
Oh,
Roger
wait.
then I write the 10?
I left it in my truck.
we have husky for French on.
I pulled it. It's easy, I have.
Garrett, you say that?
Brady.
You have a calculator that needs charged, Brody?
What?
You have a calculator that needs charged?
It's in my truck.
I have one that needs charge.
A graphic one?
Yeah. No,
And they pulled out his phone.
this one. Gosh.
I can charge it.
That's a chunky calculator.
How many calculators you got?
Three.
Three?
Yeah.
In,
What you need? Hey, what you need three for? Take one dice like that.
So they just use the other one.
Well, that's.
That must mean you really love doing math, you got all those calculators.
No.
That's what that means.
That's what he has all.
10 more minutes until you get help. You said 10 more minutes until I'm out of help. I hate math so much.
Bring in
I think I'm good at
your
it.
calculator.
Guys, I don't know if you can believe it, but I used to be smart. Like, I won so many awards
Bring in
in
your
3rd grade.
calculator, I think I can charge it for you.
I know. It
Yeah,
comes
thanks.
easier for me, but sometimes I think it's just 6.
You might wanna put
Like,
some
I-
batteries in here, Garrett.
I won student of the year in 3rd grade.
There's no battery.
So,
Oh.
I never got that. I just got that.
That I can't help with.
I don't think you were.
did you know?
Yes.
Yeah, batteries.
Did you know it was a little
She
bit?
saved all of it. She saved all of it for
She's
her help,
evil.
apparently.
She's evil.
It is,
We were
yes.
telling her, like, you're not
We won't need it much this year, but
She's
next
done
year
it.
you will
She's
need
done it for 6 years.
Alright.
Because they like changed it to where it's 6, 7, 8, 8 graders.
All right, I'm not gonna take the time to go through this next one. It's the same basic idea. The only difference on this one here, I'm gonna draw the picture real quick. This one, we got 4 points.
I think there's only like 115 more days.
Who's counting, right?
Counting. No, not left until I can like legally drop out. I'm counting down to my 16th birthday.
Are you actually gonna drop out?
No.
Why are you counting it down then?
Why not?
Okay, so this is what we call a parallelogram, okay? Couple of things that I would tell you about it real quick. Obviously, it's four-sided figure. We saw one like this a little bit ago. Okay, perimeter. Guys, let's keep the talking to a minimum, okay? Pay attention. We're gonna add up all 4 sides. That's the big difference here. Okay, these 2 sides would be really easy to come up with because they are horizontal. These 2 are diagonal, so you would have to use the distance formula. Takes a little bit of time, yes, but that's really the only way to get there. If we were gonna do the area here, then when I draw my height in, we're gonna draw the height perpendicular to the base. So that would be my height right there. So the base would be 4. My height would be 1, 2, 3, 4, 5, 6. And you could do the area. So the area wouldn't be too bad here. The distance is the one that takes a little bit of time. You got to use the distance formula. Okay. Let's go to the next page. Okay, we're building a shed in the backyard. The diagram shows the 4 vertices of the shed floor. Each unit in the coordinate has represents 1 foot. Okay, so instead of unit squared here, this would be feet squared. Every unit is a foot. Find the perimeter and area of the floor of the shed. Okay, let's start with perimeter here. Okay, if I go from 2,7 to A7, yes, you could count, but because the 7 stays the same, how far am I moving to get from 2 to 8? 6, okay? So you could either count, or you could just do a little bit of quick math saying we move 6 units to get from 2 to 8. Same thing here, 8,7 to 8,2. To go from 7 down to 2, we're moving 5 units. Okay, this is a rectangle. So we know lengths are the same, widths are the same. Perimeter here now would be pretty easy. 2 times 6 plus 2 times 5. Okay. And then we're going to label it. In this case, we're not going to label it units because they tell us that every unit represents a foot. So this would be 22 feet. Okay, 22 feet around the outside of that shed. Okay, the area is base times height. The base is 6. The height is 5. We already know that it's perpendicular because it's vertical and horizontal, right? Vertical and horizontal makes a 90-degree angle. So we already know that there's a 90-degree angle there. And so 60 times 5 would be 30 feet squared.
I'm not good. I just guessed
Okay, first thing we're going to do here, determine the vertices. So we're looking for some points. The answer is here points, right? Not area, not perimeter, but the answer here is points because they're looking for a perimeter of 20. First thing we got to know is what would the length of this rectangle be? So we're going to go 1, 2, 3, 4, 5, 6. So right now we know the length would be 6. Hey, so we know that the opposite side would also be 6, right? So if I was going to do perimeter, I would do 6 plus, we have 2 widths, right? But what would be true about the 2 widths if we had a rectangle? They'd have to be the same, okay? So here we have 12. If I subtract 12 from 20, what do I have left? 20 minus 12. 8, right? So 8 is left, but I need 2 sides that add up to equal 8. So what would the length of each side have to be, right? So W has to be 4. And we got 2 of them. Okay, now here's the question. It doesn't really tell us a whole lot of information about what direction we're moving to make our rectangle, right? So we have a couple of options. We could go 1, 2, 3, 4, and go here. 1, 2, 3, 4, and go here. We also could go down and go here and here. Okay? So we actually have 2 different rectangles that we could make. There would be one of them. Okay? So there are 4 points that we're looking for here. We want to identify what the ordered pair is of those 4 points. Okay? So let's go to this one here. To go to this one here, remember we're always going to start at the origin. So we're going to move left 2, and then we're going to go up 1, 2, 3, 4, 5, 6. So we're going to go left 2, up 6. For this one here, we're going to go right 1, 2, 3, 4, and we're still going to go up 6. Okay, so that would be one of the rectangles I could make. Or if we do the bottom 2 points, okay, this one would go left 2, down 2. And this one would go 1, 2, 3, 4, down 2. Okay, and so it kind of depends on how the question is being asked. Give me one pair of coordinates that would give me a rectangle. In this case, I came up with both of them because it just says determining the remaining vertices of a rectangle with a perimeter of 20. So probably wouldn't need both of them, but we could come up with both of them if we have to. Okay, the last one on this figure here. This figure does not have a name to it, okay? Or at least a specific geometric name. What we call this one is a composite figure.
That's like a layout.
It's kind of like, I mean, it could be like a pool, right? Maybe we make a pool in the shape of this, like maybe this is the deep end down here and this is the shallow end, whatever. But it's just some type of shape, right? And so when we find the perimeter and area, we can't really use a formula that we have. What we have to do is we have to break it up into smaller parts. And so what I like to kind of do here is break it up into like 2 rectangles. And we have the top one and we have the bottom one. Okay, we're going to find the perimeter and then we're going to find the area. Okay, so first of all, we're going to find the perimeter of the top piece. Has a width of 3, a length of 6. So that would be 2 times 3 plus 2 times 6, which would be 18. So the top part would be a perimeter of 18. Okay, but here's the problem with that. There's this little piece here, right? And that's not really a piece of the figure. So we would actually have to take that piece off. And so that makes that a little bit tricky, right? So probably there's a couple of different ways that you could go about this, okay? To find the area, it's probably best to do it this way. To find the perimeter, what would be the length of this piece right here? 4. Yep.
Okay, I thought you meant like the up and down one.
And then this one here? The whole thing is 5. This piece here is 3. So the leftover here would be 2. Okay. So probably it's not best to do like the top and bottom here. For the area, I would say yes, it is. Okay. Here, it's probably best because you got to remember to take out the piece on the inside. We don't want to have to worry about that. So for this one, we're going to simply say 6 plus 3 plus 4 plus 2 plus 2 plus 5. We're just going around the outside. 6, 3, 4, 2, 2, and 5. If we add all that up, 6 and 3 would make 9. 9 and 4 would make 13, 15, 22. So 22 units. Anytime we don't have a label given to us, we'll just go generic. Okay, area. Okay, this is where splitting it up into 2 parts is probably better. Okay, the top part would be 6 times 3. The bottom part has dimensions of 2 and 2. It's a square. So we have 18 plus 4, 22 units squared. Okay. Now, kind of weird, right? The perimeter and area are the same. Is that going to happen very often? No. Probably not. Okay. Very seldom will both the perimeter and area be the same number. In this case, they happen to be. Okay. That's all we got. We do got big ideas today.